Okay, kids, so this is Unit 2, Lesson 3. You're going to be learning about the triangle inequality theorem, the angle and side relationship in a triangle, and you're going to learn how to construct a triangle congruent to another triangle by side, 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 congruent to side, 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 and side angle side, congruent to side angle side. Okay, so let's start with the triangle inequality theorem. Okay, this theorem tells us that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. All right, so what that means drawn out is, let's say I have this triangle and I call this side A, this side B, and this side C. That means that A plus B is greater than C. Strictly greater. It cannot be equal to it. A plus C would be greater than B, and then B plus C has to be greater than A. That's what this theorem is stating. So, if you have a measure of 10 on one side of a triangle, right, and let's say this side is 4, and I say, okay, I want to make this other side 5, you're not going to be able to make the triangle, because think about it. The side of 4 and the side of 5, if you tried to connect them, they would land on this side. You wouldn't be able to make a hinge, okay? You wouldn't be able to get a vertex because those two sides would not meet. If they added to 10, you still wouldn't be able to make a hinge because it would literally take up the entire side. So you need the sides to add to more than the third side. All right? So no, this does not make a triangle. These sides, okay, will not make a hinge, make a vertex. Let's take a look at some examples. Do these three sides form a right triangle? Form a triangle. So number 1, 3, 3, 4. Okay, so you could do 3 plus 3 is greater than 4. Is that true? Yes, it is. Okay. Now, you could add the 3 and the 4, but the 3 and the 4 will definitely be greater than 3. So the thing is, if you want to take a shortcut, okay, we can just add the two smallest sides to see that they're greater than the third side. That their sum is greater than the third side. Okay, so this answer is yes. Number 2, 5, 5, 5. Anytime you have an equilateral triangle, the answer will always be yes. You don't even have to check it because 5 plus itself is always greater than 5, guys. 5, 6, 12. What's that answer? No would be the answer, because 5 plus 6 is not greater than 12. It has to be greater. How about 8, 8, 16? That seems like that could be a nice isosceles triangle, right? No, because 8 plus 8 is not greater than 16. It's equal to it. It has to be strictly greater. So keep that in mind. Here's another type of question they ask you on this topic. When given two sides of a triangle, okay, find the third side, find a range of values for the third side. By doing the following. Get the difference. Now, when you get this difference, it has to come out to be positive, kids, okay? You know what? I'll just write difference with absolute value around it so you know that it has to be positive. Difference of the two given sides. I'll say absolute value. Has to be less than the third side, strictly less than, which has to be less than the sum of the two given sides. Okay, so for example, this was a Regents question. If two sides of a triangle measure 4 inches and 7 inches, what are the possible measurements of the third side? Okay, so I'm going to subtract these two numbers. 7 minus 4 has to be less than the third side, which has to be less than 7 plus 4. So that means that the third side has to be between 3 and 11. So can the third side equal 3? No, because it has to be greater than 3 and less than 11. Can it equal 11? No. Can it equal 4? Yes. Can it equal 10? Yes. How about 3.1? Yes. Okay, so not 3, not 11. Okay, 4 works. 5 works. 3.1 works. 10.9 works. You have to be between 3 and 11. Here's a graph. This graph will help you to realize the values. This is a graph of the solutions. They have to be between 3 and 11, not including 3 or 11. Okay, so the next thing that we're going to go over is the relationship between sides and angles in triangles. All right, so you're going to copy this down. I'm going to say it first and then you'll copy it. In every triangle, the longest side is opposite from the largest angle. In every triangle, the longest side is opposite from the largest angle. All right, so this should make sense. So let's say I make a really large angle here, right? Now, look at the picture. Is it obvious to you that this side A has to be the largest because it's across from the largest angle? So let's say angle A is 130 degrees. And then we'll say angle B is 10 degrees. Okay? and then angle C, we'll say that's 40 degrees. So the largest side, you know what, I'm going to switch the 40 and the 10 just because I don't want you to have a misconception based off of my crummy picture here. Okay, so I'll say this is 40 and this is 10. So you could see that A is the largest, right? Now look at where it is. It's across from the largest angle. It makes sense because think of it as a mouth. This mouth is open, right? So it would be like the opening would be wider. So this distance from B to C has to be greater. Another thing you could think of is when you have a right triangle, at some point, a teacher told you that the hypotenuse is the longest side, right? So let's say this is 3, 4, 5. The hypotenuse has to be the longest because it's across from the right angle. The other two angles, okay, can't be 90 degrees because there's only 180 degrees in a triangle to begin with. Okay, so along with this first theorem I gave you, in every triangle, the longest side is across from the longest angle, then it would stand to reason that in every triangle, the shortest side is opposite from the smallest angle. Now, I'm not going to write the next one, but you can if you want, or if you feel it's common sense at this point, you don't have to write it. In every triangle, the middle-sized side is across from the middle-sized angle. Now, vice versa, this works the other way. So we can switch all these statements around. So in every triangle, the largest angle is across or opposite, from the longest side. Make sense, guys? So you can go both ways with this. Okay, let's take a look at some examples of this topic. Okay, put the sides in order from smallest to largest. So let's say we have this triangle RST, and we'll say R is 70 degrees, S is 50 degrees, T is 60 degrees. So I want to start with the smallest side. So the smallest side would be across from the smallest angle, which would be RT. The middle-sized side would be across from the middle-sized angle, so that would be RS. And then the largest side would be across from the largest angle, TS. Okay, so that's how it would work. Now they can try to trick you, so let's say we look at this example. And let's say that this angle is 30 degrees. And they don't tell you the other angle. Here's the thing, guys. In a right triangle, the two acute angles have to be complementary. Write that fact down. That's going to come up all year, especially when we do trig. In a right triangle, the two acute angles are always complementary. So they always add to 90. Okay? So angle J has to be 60 degrees, but I don't have to give it to you. So now when we put these in order from smallest to largest, the smallest angle is 30. So that means KJ is the shortest. 60 degrees would be the middle-sized angle, KH, and the longest side would be the hypotenuse, as it always is in a right triangle. Okay, so here's another one, okay, where we try to trick you. This is 110 degrees, angle F. We'll say up here is 20 degrees, 50 degrees. Okay, but I'm not going to give you the 50 because you can figure that out. And you have to be used to the way these questions are written. So no one's going to give you the 50 because you can figure out the 50 because there's 180 degrees in every every triangle. So kids, when I put these in order, the smallest side would be across from 20, which would be FE. The middle size side would be across from this 50 degrees, which would be DF. And the largest side is across from 110, DE. That's how that works. Okay, how can they make this more difficult? Because you understand a topic in math and then all of a sudden you see a question and you wonder what's going on. In a triangle, the measure of angle C is 7x plus 8 degrees. The measure of angle A is 7x plus 6 degrees. And the measure of angle B is 8x minus 10 degrees. Write the sides in order from greatest to least. So now I just made the problem a lot more difficult because you need to find x first. So there's 180 degrees in a triangle, so we're going to add all these angles up to 180. So we get 22x, and then I get plus 4 equals 180. Subtract the 4, and then divide by 22. Okay, so you get x is 8, right? So now when I sub this back in, I get 7 times 8, which is 56, plus 8 is 64 degrees, right? Over here, I get 7 times 8 plus 6, which is 62 degrees. Then I get 8 times 8 minus 10. 64 minus 10, 54 degrees. Okay, make sure that these actually add to 180. It's a good built-in check. Yep, they do. So I want to write the sides in order from greatest to least. So now you need to put on your thinking cap here. The largest angle is C. Well, C would be across from AB. You can draw a triangle if you want to see it, but it only makes sense because when you're getting in any problem, when you're getting the side across from an angle, the angle can't be included in the side, guys, right? So the next largest angle is angle A, so angle A would be across from not A, but CB. Make sense? And then the last angle, okay, was angle B. So angle B would be across from AC. Now be prepared to work in reverse. List the angles in order from least to greatest. And so we give you some picture. Okay, here's C, A, B, all right. We'll say this is 5, 7, 9. So if I want to put the angles from smallest, the smallest angle would be across from the smallest side. That would be angle A. Then the middle-sized angle would be across from or opposite from the middle-sized side, which would be angle B. You know what? I'm going to make the less than signs red, okay, because it just looks confusing. And then angle C, all right, would be the largest angle because it's across from the largest side, 9. Okay, kids, there you go. So next up, I'm going to teach you a couple of constructions. I'm going to teach you a side-side-side construction. Now I can give you any 3 sides. So for example, let's say I give you an isosceles triangle. And I just give you 2 sides. That's all I have to give you, because an isosceles triangle has 2 sides that are congruent. The third one doesn't necessarily have to be congruent, so I'm going to make it so that it's not. So if I am going to construct an isosceles triangle, okay, with the legs the shorter side. Okay, so the first thing is I have to have a place to copy this onto. So I need some ray. So I draw a random ray. Okay, so to start this construction, you're going to put your bullseye on one end point of the segment you're copying. And then you're going to move your compass so that the pencil passes through the other end point of your segment. Then you go down to where you're copying it, and you're going to use the same setting that you just used above. So the next thing you're going to do, I want to copy this leg, okay, but I'm going to copy the leg twice. So I'm going to put my bullseye on one end of my leg, and what I'm doing is I'm making my setting, I'm setting my compass so that my pen is going to pass through, okay, the other end point of my segment. So I make a mark to show that I did that. Then I put the bullseye where I had the bullseye previously. I make a mark, but I'm just making it above my ray. Then I have to go to this intersection point, the first intersection point I got, put my bullseye there, and swing an arc as well. And then I take that intersection, kids, and I just attach that point to each of these points. And so this is an isosceles triangle. These 2 sides are congruent. And so the legs are the shorter side, and this is the longer side. These are legs. So the shorter side, the longer side here is called the base. Okay, one more construction, and if you have trouble getting them from this video, I can understand that because you can't see me. All right, but it's still a good introduction. We're going to do the side angle side construction. So the way this is going to work is I'm going to give you a triangle. We're going to copy 2 of the sides and the angle between them. So we'll do a side, then we'll do an angle, and then we'll do a side. Okay, so I had to pick 2 sides, so I'm picking BC and CA, and then I had to pick the angle between them. All right, so you start off, I wrote C down on the ray that I'm copying this onto. So I'm going to start by putting my compass on C, and I'm going to open my compass so that my pencil, okay, mine is an Apple pen, all right, passes through A. So then I swing my compass to show that I measured CA. Now I go down to the bottom where C is, I put my bullseye on C, and I make the same arc that I just had above. So this is A prime. I'll call this C prime. Now I'm going to do the angle next. So to do the angle, I can make any arc I want with the center on C. So I put the bullseye on C. I make any arc, okay, that pleases me here, that intersects both sides of my angle. Okay? So After I make, okay, this arc that intersects both sides of my angle, I go down to C prime and I repeat that. So it's the same setting. This is the first step to copying an angle. So then I measure the distance from, I'll just call this D, this point D, and this point E. I measure the distance from D to E. So I'm going to put the center, the bullseye, on D, and I'm going to have, okay, my compass pass through E. Okay, so I have it on D. I make my Apple pen, okay, pass through E. Then I go down to D prime. I repeat that. So this is E prime. I'm going to draw a ray from C through E prime, and then I just copy segment CB. So I put the compass, the bullseye, on C, and then I make a mark through B to show that I measured this. Okay, so then you go over to C prime, repeat that. So this mark over here is B prime, and then I connect E prime to A prime. So these triangles are congruent. I'll be doing this in class as well, and that's your introduction to it. That's called the side angle side. Thank you.